solution, suspension, and colloids. Before going to explain about solutions, what is the difference between homogeneous and heterogeneous solutions, heterogeneous mixture, students? Difference between homogeneous and heterogeneous mixtures.
Homogeneous mixtures are where the components in the mixtures are completely mixed. Like if you explain it according to Tyndall effect, then you can't see the beam of light passing through it. But in a heterogeneous is not fully dissolved in the solvent.
Okay, okay. Here, according to Sandra, they mix uniformly. Even Dhanusha same thing. It is homogeneous has uniform composition, uniform composition throughout the mixture. Heterogeneous, there is no uniform composition. So we can distinguish the layers also, solute, solvent. Like that. So that is the difference, main difference between homogeneous and heterogeneous. Now, solutions come under homogeneous or heterogeneous, students. These true solutions come under homogeneous or heterogeneous. Correct answer. The correct answer. Solution is true solutions under homogeneous mixtures. Suppose salt, if you dissolve it in water, you can't distinguish salt and water after solution. So there is uniform solution, clear solution you can see. It's called true solutions. Whereas sand, if you keep it in water, or chalk powder, if you keep it in water, you can distinguish the solute and solvent. Okay. Those are heterogeneous mixtures. Even so, now I'm going to define solution. This is a homogeneous mixture of two or more components. This is a homogeneous mixture of two or more components. Homogeneous mixture of two or more components whose composition vary with certain limits. Certain limits. Certain limits are by changing some factors, this composition will change. Suppose 5 gram salt can dissolve in 100 ml of water. Simply I'm telling some numbers. So if it forms saturated solution, by saturated solution, afterwards no more solute can be soluble in water. So here better I'll use saturated and unsaturated solution also. So solution is homogeneous. It is a homogeneous mixture of two or more components whose composition vary with the certain limits. Composition. So for this meaning, I'll tell you. If we increase the in normal conditions, 5 gram of salt can dissolve in 100 ml of water. If you heat this mixture, more solute can dissolve. Suppose it can be 6, it can be 7 also. Little more solute can be dissolved. And normal condition, normal temperature, only 5 gram of solute can dissolve and form saturated solution. If you heat it or if you increase the temperature, more solute can be soluble. That is the reason I told whose composition vary with certain limits. So now solution contains two components. Solution contains two components. What are the two components, main components? solute and solvent. The two components, solute and solvent. Solute and solvent. Which is in minor quantity, students?
Solute.
Out of solute and solvent in solution, which is in minor quantity? Solute is in minor quantity. This one is in major. Solute dissolves in solvent. Next, for any solution, solvent is only one. Solvent, more than one solvent is not possible for any solution. Only one solvent. But solutes can be more than one also. Can be possible. Homogeneous, heterogeneous mixes I explained. After solution item. Solution is a homogeneous mixture containing two components, solute and solvent. Solute present in minor quantity, solvent present in major quantity. Next one, types of solutions, students. I heading types of solutions. Types of solutions. This saturated solution. Anyone, can you tell what is saturated solution, students? Saturated solution. Name itself we can make out. Saturated. I am saturated with my food. So in function and all, if you go to relatives, if they give food, they are giving more food, will tell I am saturated. What is the meaning of saturated? Meaning you don't tell them. Meaning you can tell. Solvent cannot dissolve any more solute. Dhanush, correct answer. Okay, very good. Saturated solution means it is already saturated with the solute. Afterwards, no more solute can be soluble. No more solute can be. Change the temperature, little more solute may soluble. Students, can you hear me properly?
So your voice keeps
Sometimes here I
breaking.
am getting like your internet connection is unstable. Okay. Saturated solution. Solution in which no more solute can be dissolved in solvent. No more solute can be dissolved. Is called saturated solution at constant temperature. Next one, unsaturated solution. Unsaturated solution. Still, how many chapters are there, students, in your second module?
This is the last chapter, sir.
This is the last chapter. Okay. Unsaturated solution. Solution in which more solute can be soluble. Solution in which more solute can be soluble. Soluble at constant temperature. Constant temperature. Next, one more solution is there, that is called supersaturated solution. Supersaturated solution. Solution in which more solute can be soluble with increase of high temperature. Otherwise, use saturated solution. Saturated solution in which more solute can be soluble with increase of temperature. Increase of temperature is called supersaturated solution. Suppose saturated solution with 5 gram of solute, 5 gram of solute can dissolve in 100 ml of water. Afterwards, no more solute can be dissolved. If you increase the temperature, just now I said little bit will dissolve, 1 or 2 grams extra may dissolve. Such type of solutions are called supersaturated solutions. Supersaturated solutions. Some people normally at home they have less only, but if they go to functions and all, they'll have more than normal. Those are called supersaturated people. Supersaturated people. Correct now. Afterward, they'll go to this. They run for Eno, soft drinks and all. Getting when they have excess food digestion problem, they get no. The super saturated, super saturated, they'll have more no that time they need. Super saturated solution. Same thing here when we increase their external factories, they are having food outside. Here external factories increasing the temperature. Okay, super saturated solutions. So here you have to write after saturation also they are having more. Bakasuras. Saturated solutions in which more solute can be soluble. With the increase of temperature. With increase of temperature. These are called supersaturated solutions. Saturated, unsaturated, supersaturated solutions. And based on the solvent and solute phases, solutions are also classified into gaseous solutions, liquid solutions, and solid solutions. Can you give one example for solid solution, students?
Alloys.
Very good. Alloys are the solution. Solute and solvent both are in solid state, isn't it? Bronze, brass, those are all the examples of copper dissolved in gold. All are the examples of zinc amalgams and all examples of solid solutions. Can you give one example for gas dissolved in solid? Gas dissolved in solid. I think this you may not be knowing, but organic chemistry you will get this one. I'll give one hint. In organic chemistry you will get it. Hydrogenation of alkenes. Have you heard? Addition of hydrogen to alkenes. Conversion of unsaturated compounds into saturated compounds by adding hydrogen. That happens in the presence of nickel or platinum or palladium catalyst. First, hydrogen gas settle on the surface of catalyst. What is the catalyst here? Palladium or nickel or platinum. Okay, that is like a solution only. gas is settled on surface of solid. That is also example for solid solution only. And liquid present on solid, present in solid. Mercury amalgams are there, no? Mercury is liquid over there, and if it is with sodium or any other metal, then it is called liquid solid solution. Solid solutions. In solid solutions, solid act as a solvent. Solvent is in solid state. Next, on liquid solutions, you will get many examples. Liquid means ethanol in water. You can take ethanol will dissolve in carboxylic acids in water. They are all dissolved in water. Next one, gas in liquid. Can you give any example, students? Gas dissolved in liquid. Gas dissolved in, very good, carbonated water. Carbon dioxide gas with high pressure we are send it in water. They form carbonic acid. And one more example, oxygen dissolved in water. Oxygen dissolved in water. That is also example of liquid solution. Okay, those are all examples of solid solutions, liquid solutions, and gas solutions. Next side heading, here onwards it is important, students. Methods of expressing concentration of solution. Methods of expressing is an all introduction only. Here onwards our topic starts. Methods of expressing concentration of solution. First of all, what is concentration, students? Concentration is nothing but number of moles of solute present in 3 liter of solution. Concentration. Not only this method, we have different methods. That one is mass percentage, volume percentage, molarity, normality, mole fraction, ppm, parts per million, parts per million. Those are all the methods to express concentration of solutions. I'll start with the mass percentage. First one is mass percentage. What is mass percentage, students? In ninth standard also you had, I think. What is mass percentage? Tripti, correct answer. Okay. Dhanush, correct answer. Mass of solute, it is the ratio of mass of solute to the mass of solution into 100. Yes, Tanmay, correct answer. Very good. Mass of solute to the total mass of solution into 100. Percentage of mass is equal to solution into 100. Suppose if I give 10 percentage of glucose solution, what is the meaning, students? 10% of glucose solution. What its name? 10% of glucose solution. Dhanush, no. Yes, Dhanush, no, you are correct. 10% of glucose solution means 10 gram of glucose. Sandra, correct answer. Very nice. 10 gram of glucose in 90 gram of water. 90 gram of total it should be for 100. So 10% of glucose solution. Wherever you get take 10 gram of it means 10 gram of solute is glucose. Present in 90 gram of 90 gram of. Find out, calculate the mass percentage. Note down, students. Calculate the mass percentage of mass percentage when 5 gram of 5 gram of NaCl dissolved in 50 gram of 50 gram of aqueous solution. Aqueous solution. That's all. What is the mass percentage, students? Mass percentage of that solution. And my correct answer, Sandra correct answer. Remaining students send first. 5 gram of NaCl dissolved in 50 gram of aqueous solution. Dhanush, how did you get that? What you took? You tell me. 9.09. See, students here, they gave mass of solution directly. So don't add again 50 plus 5. Some students they might have taken 5 by 55. Don't take 5 by 55. If they give in a dissolved in 50 gram of water, if they give, you can add both 50 and this solute mass. Already they have given mass of solution only, aqueous solution I mentioned. So you can take it directly. 5 gram of NaCl present in 50 gram of solution. They only mentioned it, solution. The mass of solution only they give directly. Tripti correct now. That time directly you can substitute. So observe carefully. For that purpose only I gave. To be 10%. 10%. Got it, students? Mass percentage. If you know mass percentage, volume percentage, same. Just instead of mass, we will write volume. Next one, volume percentage. Or percentage of volume. Same formula, students. Volume is equal to volume of solute to the volume of solution into 100. Volume of solute to the volume of solution into 100. Same as mass percentage, but here in terms of volume, 5 ml of particular solute present in 50 ml of particular solvent, then what is the volume percent? Like that they'll ask. Same. Next one, molarity. 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 Here, molarity formula I'll give first, students. Molarity, it is represented with capital M. which is equal to number of moles of solute to the volume of solution in liters. Volume of solution in liters. N is equal to number of moles of solute. V is nothing but volume of solution. Volume of solution. V is nothing but volume of solution. Volume of solution. So if you want to define this one, molarity is defined as the number of moles of solute present in 1 liter of solution. Number of moles of solute present in 1 liter of solution is called molarity. What are the units of molarity, students? Units. Don't tell capital M. Tripti, correct answer. Mole per liter. Very good. Dhanush, correct answer. Because N will measure in terms of moles, volume, mole per liter or mole liter is inversely proportional to temperature. Inversely proportional to temperature. Inversely proportional to temperature. Now, most of the case they are giving weight of solute and solute name they are giving. So better will convert in terms of weight of solute and molecular weight of. You know, N is equal to weight by gram molecular weight or molecular weight. So here I will use gram molecular weight. Gram molecular weight. From the basic equation, we can write like this: weight by gram molecular weight of solute into V in liters. If you want to convert in terms of milliliter, because volume also every time they are giving in terms of milliliter only. So molarity is equal to weight by gram molecular weight. So to convert liter into milliliter, multiply 1000. Now we get weight volume in terms of milliliter. This is one final equation, final form, molarity. V is volume of solution. Already again. Shall I give one problem, students, upon this? To try, I will explain. Get it's okay. Otherwise, I will explain. Calculate the molarity of the solution in which 5 gram of NaOH. Calculate the molarity of solution when 5 gram of NaOH dissolved in 500 ml of solution. 500 ml of solution. 500 ml of egg-based solution or anything you can use. Find out, students. Tripti, I think correct. Srivani was also correct. 1 minute. 5 gram of NaOH, right? Dissolved in 500 ml of solution. Okay. Now what you have to do, molarity is equal to weight 5 gram by molecular weight of NaOH. Sodium is 23, oxygen atomic mass 16, hydrogen 1, 40 into 1000 upon 500. 1/4. Yeah, Tripti correct. Sandra correct. Dhanush correct. Srivani correct. So 1 by 4 will get, which is equal to 0.25 molar. 0.25 molar. Got it, students? Molarity basic problems like this they are asking. They'll give the weight of solute, weight of volume of solution. They'll ask you to find out molarity. Or sometimes molarity they are giving, solute they are mentioning, and volume they are mentioning. They are asking weight of solute required to prepare particular concentration of solution. Here we have some problems because molarity is important. Can you do this problem, students? Calculate the molarity, the density of the aqueous solution. Yeah, to do this one, it means somewhat different. To try, I'll explain if you do not get. Calculate the molarity of KCl, KCl, if the density of 20 percentage aqueous, 20 percentage aqueous Ki, sorry, instead of KCl, Ki you take because they mention clearly, no density. KCl, Cl you cut it, student. Ki you take. Calculate calculate the molarity of Ki if the density of 20 percentage mass by mass, 20 percentage by mass. If you write, it will be well and good. 20 percentage by mass of aqueous Ki is 1.202 gram per milliliter. 1.202 gram per milliliter. They are asking molarity. It is there in textbook also, students. Molarity of Ki, it seems. Density of the solution they mentioned. Density of the solution is 1.202 gram per milliliter, and mass percentage also they gave. Mass percentage is equal to how much? 20%. Molarity of Ki, the density of the solution is 1.202 gram per milliliter. Here, mass percentage, if they give, what information we can get, students, from mass percentage? You think first. Mass percentage is nothing but mass of solute by mass of solution into 100. Here, mass percentage 20 means 20 gram of Ki is present in 80 gram of water. 80 gram of water, isn't it? 80 gram of water. So mass of solute we got to know 20 gram. Mass of solvent we got to know. So 20 gram of Ki present in 80 gram of what? Solvent. But to find out molarity, what we need first you write. Weight of solute by gram molecular weight of solute. That anyway, weight of solute we have, gram molecular weight of solute also we have. We know by because formula is there, now we can find out. 1000 by volume of solution we want. volume of solution, how we get? Here density they have given. Density is equal to mass by volume. Isn't it, students? Density is equal to mass by volume. Here density is nothing but density of the solution. Density is density of the solution. Mass of solution by volume of solution. Density of the solution is equal to mass of solution by volume of solution. Otherwise, you can do one more thing, students. 1.202 gram per milliliter means per 1 ml, in 1 ml how much amount of solute is present? 1.202 solute is present. For 1000 ml you calculate. 1000 ml how much you will get? 1202 gram of. This is the mass of total solution. Instead of that, one simple method is there, becoming little. 1 minute, students. Yeah. They are asking molarity of 20 gram. Once you do this one, students, molarity, one simple method I give, mass percentage into, because in competitive examination and all not required this much lengthy method, by molecular weight of solute. I'll tell you how we'll get this one. Molarity is equal mass percentage 20, density how much they give? 1.202 into 10 by Ki molecular mass. Potassium how much? 39 around. Iodine 127. 9 plus 7, 16. 6, 166. Find out this one, students, how much you are getting here. Harman, once you do this calculation, 200 200 into 1.2, 1.4, correct. Yes, correct. This method you use, students. This is better. Instead of finding density of the from density finding volume of the solution. This I don't want. From this again, volume of solution. Yeah, approximately 1.4. Correct, Sandra. Correct. 1.4 mole you can take. Mass molarity is equal to mass percentage into density into 10 by molecular weight of solute. Same thing. This formula you use. I'll tell you how we got this one. Molarity, you know, weight by gram molecular weight into 1000 by V in ml, isn't it? Mass percentage formula, mass of solute by mass of solution into 100. Into 100. This 100, let it be. Here, mass of density they have given, no, mass of solution by volume of solution. Volume of solution. We want to convert mass of solution into density and volume. So mass is equal to D into V. D into V. Otherwise, V is equal to M by D. This is better instead of V if you remove would be better. Mass of density of solution is equal to mass of solution by volume of solution, isn't it? So now volume of solution is equal to mass of solution by density of solution. Density of solution. Substitute this term here. Mass is equal to weight by gram molecular weight for time. Okay, I will write one step by extra, nothing will happen. 1000 upon instead of volume, I am writing this one. I am substituting this one. Mass of solution by density of solution. Density of solution. Hope you might got to know this one. Weight by mass of solution. I am keeping mass of solution. This 1000 I am splitting into 110. 100 into 10 to 10. Here denominator is there. No, density will go up by gram molecular weight. Observe carefully, students. Mass of solute by, this is weight of solute, no? Mass or weight of solute by mass of solution. But into 100 is there, no? We can write mass percentage. I am taking X here. Into D into 10 by molecular weight of solute. Understood, students? In this way I did. Easy, students? So directly we'll get answer here. Nothing I did. From density of the solution, volume of solution I am getting. That volume term I am replacing with mass of solution and density of the solution. We'll get now in terms of mass percentage density. So that you can do directly X into D into 10 by gram molecular weight. So I asked you whether we are getting same. Already some students did on 1.448 by using that method, above method. I wanted to know whether we are getting same or different. You told it's same. Use this method. If you want this derivation also, you can use. You can copy. Is it clear? Next. So mass percentage. Mass percentage, if they give density of the solution, they have to give students to find molarity. If they do not give, leave and come. I'll put case upon them. Next one. Upon mass percentage, they ask one question. Suppose that is solution was prepared by dissolving 25 gram of sugar into 100 gram of water. Calculate the mass percentage asked. Can you do it, students? Suppose that a solution was prepared by dissolving, practice question, students, 25 gram of sugar dissolved in 100 gram of water. Calculate the mass percentage. Easy it is. Dhanush, correct answer. Arman, correct answer. Srivani, first she sent. Sandra, next. Tripti, correct answer. Very good. 25 by. Here we have to add students because they have given solvent mass only. 25 plus 100. So here 25 by 125 means 5 times it will get cancelled. 100 by 5, 20%. 20%. So molarity, all the properties we got to know, final formula we got to know, molarity and mass percentage relation, if they give density, how to find that also we got to know. Next, one more concentration term, ppm, part per million. Parts per million. First, I'll give the formula, then I'll explain about this. ppm is equal to number of parts of one component one component to the total number of parts of all the components into 100. Sorry. Into 10 power 6 students. Into 10 power 6. It is very generally in case of automobiles, bikes, cars and all, that pollution check certificate is there. Now you just check that they'll mention the quantities in terms of ppm. So this concentration term is used for minute quantities. You want to express the concentration, minute quantity, for minute quantities, use this one, ppm, parts per million. Will make it will make it bigger and it will show parts per million. Number of parts of one component by total number of parts of all the components in the solution into 10 to the power 6. All these things they will only give direct substitution only. Mole fraction. Mole fraction. Mole fraction is nothing but, here mole fraction is represented with the x. The advantage of mole fraction is we can find out the concentration of solute and solvent, means all the components, whatever the components present in the solution, we can find out individual concentration of all the components. We can concentration of all the components we can find out in this, by using this method. First of all, what is, suppose solution contain two components, one and two, or xa and xb also you can take, two components are there. Mole fraction of first component or a component, if you want, better we'll use a and b components. So xa is equal to n is nothing but number of moles of a component by total number of moles of all the components. If more than two are there, we'll write Na plus Nb plus Nc. So from this, how can we define, students, from this formula? Mole fraction is the ratio of number of moles of one component to the total number of moles of all the components. If you want to write the definition, it is the ratio of number of moles of one component, ratio of number of moles of one component to the total number of moles of all the components. If solution contain two components A and B, if solution contain binary solution, what we say, if only two components are present, is called binary solution. two components A and B, then mole fraction of A XA is equal to mole fraction of A XA is equal to Na by Na plus Nb. Here, yes, mentions here, students. Na is nothing but number of moles of component A. Component B. Suppose if you want to find out mole fraction of component B, mole fraction of component B is Nb by Na plus Nb. Suppose if you want to find out, you just add these two XA and XB, student, mole fraction of two components. You just add sum of the mole fractions of two components. Na by Na plus Nb plus Nb by Na plus Nb. How much will you get, students? It is equal to 1. Yes or no? So
Yes, sir.
mole fractions of all the components is always equal to 1. Mole fractions of sum of the mole fractions of all the components in a solution is always equal to 1. So what is the advantage of this one? By knowing, suppose here we got to know, copy it, students, is equal to 1. By knowing mole fraction of one component, we can find out mole fraction of other component. No need to use formula again and again. Advantage of this one. Suppose XB, if you know, you can find out mole fraction of XB. And does not depends on temperature. Depends on temperature. It is independent of temperature. Advantage of mole fraction is we can find out the mole fraction or concentrations of the components individually. So here, mole fraction does not depends on temperature. Formula I'll write first, then I'll give the definition. Molality. Molality is represented with small m is equal to number of moles of solute. This is same by weight of solvent. Weight of solvent in kilogram. Molality is nothing but number of moles of solute present in 1 kilogram of solvent. Number of moles of solute present in 1 kilogram of solvent. 1 kilogram of solvent is called molality. Is called molality. Independent of temperature. Temperature. Next, if you want to simplify, you can do weight by gram molecular weight into 1000 upon W in grams. If you want to write it in grams. So for same problem, we found molality also. By knowing density and mass percentage, we got to know the we found molarity and molality also how to do. Last concentration term, normality. Normality is represented with the small capital N. N is equal to number of gram equivalents present in 1 liter of solution. Equivalents. Now, equivalent is equal to weight by gram equivalent weight. Number of moles, what we wrote, students? Number of moles is equal to weight by gram molecular weight we wrote. Here, weight by gram equivalent weight. What is the difference between molecular weight and equivalent weight? Molecular weight and equivalent weight. Molecular weight directly we can find out from the formula. But gram equivalent weight, to find out gram equivalent weight, molecular weight and valency both you have to know. Equivalent weight. If you read properly, you will get the answer in that only name only. It is related to the valency. It is related to the valency. So it depends on valency. For time being, I'll give how to find out equivalent weight of different compounds. I'll give. What is our relation between molecular weight and equivalent weight? I'll give. Afterwards, I'll explain the molar normality. Because it is the important thing in neutralizations and all. Molarity and all, if you use, you may do some mistakes, but normality gives perfect answer. Now, neutralization is a perfect concept. In neutralization, normality is the perfect concentration term. So, equivalent weight. If you want to find equivalent weight of an element is equal to atomic mass of or atomic weight of an element by its valency. Its valency. Suppose oxygen equivalent weight of oxygen, if you want to find, atomic weight is 16, its valency is 2. 8. Because oxygen can form two bonds. Its total atomic mass is distributing in two ways. Like that, you remember equivalent weight, equivalently distributing. Suppose I have 10 acres land, I have two sons. Each son will get 5 acres land. That is the equivalent land region. Same thing here also. Central atom is forming three bonds or two bonds. That entire mass is shared by the two bonds equally, three bonds equally. That is only equivalent weight. Simple way you can do it. Got it, students? So if in case of element, directly you can write atomic weight of that element by valency. If it is acid, compounds, if they are compounds are class again acid, base, and salt. Three types are there. So in the acid, how to do, base, how to do. Equivalent weight of acid is equal to molecular weight of acid. This is common, student. Molecular weight of the compound is common. By if it is acid, basicity will take, students. Basicity. Again, one more problem. What is basicity? How to find out basicity? Suppose here basicity will use for mineral acids HCl, H2SO4, HNO3, H3PO4, like this. Here HCl, it can dissociate into H plus Cl minus. Cl minus. How many H plus ions it can donate, students? Only one. So its basicity is 1. So exact definition is number of replaceable hydrogen ions. Number of replaceable H plus ions. Okay. Here 2H plus SO4 2 minus. So here basicity is 2. Here basicity H plus NO3 minus 1. H3PO4. It can 3H plus PO4 3 minus. Its basicity is 3. Understood, students? For acids, what we use? Basicity. For bases, what we use? Acidity. Suppose I want to find equivalent weight of H2SO4. Isn't all if you learn first year around say you can learn extra things, students. All these basics, if you have no, you can enjoy +1 +2 both. No need to learn basics and applications at a time. You may not difficult. So here molecular mass of H2SO4 directly I am writing, students, 98. If you find, you will get the same. You will get same. By basicity is how much? 2. So 49 is the equivalent weight of H2SO4. Got it, students? If it is HCl, 35.5 plus 1, 36.5 by 1. Here equivalent weight and molecular weight same. If it is monobasic acid, equivalent weight and molecular weight same. That time normality, molarity both are same only. If I have only one son, 10 acres will go to him only. My entire property will go to him only. How much? I said I have so many, will get. Okay. Same thing. Yes, Srivani, good question you asked. Actually, I don't want to confuse you by giving that, but she raised the question. Basicity of H3PO2 is 1. I know, I think she knows the answer. Simply she asked. Srivani, correct? Truth you tell. You ask that question means you know the answer. Dhanush, he told one simple point that also can be done. In case of phosphoric acids, you can do one thing. Number of oxygens -1 you can do. Otherwise, exact reason I will tell. H3PO4 structure is like this. First preference will be given to double bond O. One double bond O will go. Next, after keeping one double bond over here, how many oxygens we have? 3 we have. 3 oxygens will be joined with 3 hydrogens. So that 3 hydrogens. Hydrogen which is connecting through oxygen only, replaceable hydrogen, students, that can be considered in basicity. Other hydrogens are not considered. If it is connecting through oxygen, then only it is replaceable. Otherwise, it is not replaceable. So basicity here it is equal to 3. Whereas H3PO3, if you see, first preference will be given to double bond O. After giving double bond O, only 2 oxygens are left. These 2 oxygens will combine with the 2 hydrogens. Then one hydrogen is free. This hydrogen you cannot replace, students. It is not replaceable hydrogen. It won't come out as H plus because it is connecting directly to the central atom. So this is not replaceable hydrogen. Only 2 hydrogens are available to replace. Okay, so its basicity is 2. So 1 why we are subtracting, every time this oxygen we can't, if this oxygen is not available, the hydrogens will be free. Hydrogens will be connected to the central atom directly. Now H3PO2, if you take, out of two oxygens, one sitting like double bond O, only one is there, that one will combine. Rest of the two hydrogens directly. Here, replaceable hydrogen is equal to 1, here 2, here 3. Okay. Srivani, got it now? So by seeing the number of hydrogens in the formula, we can't estimate the basicity. Only in this case it happens. In other case, maximum directly will take in our syllabus. Okay. Otherwise, simple thing is number of oxygens minus 1 you do. Here 4 oxygens are there now, minus 1 if you do 3 you will get. 3 minus 1 2. 2 minus 1 1. That also can be done. Clear? So this basicity we know to find out the equivalent weights of. Next one is equivalent weight of base. Equivalent weight of base. This one is simple. Molecular weight of base by acidity, I said. Acidity of base. Acidity, how to find? Here bases generally they contain OH groups. Here number of replaceable OH minus ion. Number of replaceable OH minus ion by ion. So here only one OH minus is there. Here 2, here 3. Acidities. Okay. Molecular weight you calculate by acidity. If they are more acidic, their equivalent weight and molecular weight both are same. So, shall we do one problem, students, upon normality? Calculate the normality of 5 gram of calcium hydroxide 5 gram of calcium hydroxide in 500 ml of aqueous solution. 500 ml of aqueous solution. Do it and tell me, students. Five gram of calcium hydroxide, right? Volume of the solution is 500 ml. So normality is equal to weight of solute 5 by calcium hydroxide weight. How much, students? 40 plus 2 hydroxides mass is 34. 74. Sorry. 74. This is the molecular weight. If you want to find equivalent weight, what you have to do? Molecular weight upon acidity. Acidity how much? 2. 37 will get. 37. So the normality is equal to 5 by 37 into 1000 upon 500 ml. ml and alone, right? Not required. So this, if you simplify, you will get the answer. Ten by 37. 37. Danish, once check properly.